Hello everyone, myself Vinay Kumar. Welcome to my YouTube channel. So in this particular YouTube channel, I will be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So welcome to the part 2 video of data handling. So in my previous video, that was actually the part 1 video of data handling, which is the chapter 4 of 8th standard mathematics subject. So this is actually the part 2 of data handling, because in data handling the first part was related to graphs. Like you have learnt pie chart, you have learnt bar graph, double bar graph and also pictograph. So in this particular part 2 video is the second part of this particular chapter, which is probability. So I'll be discussing probability in this particular video. So what do you mean by probability? By just looking at the word probability, it will just tell the percentage of an event occurring. For example, let's say today the weather is very much cloudy. So you may actually predict that at some part in the day, at any time in this particular day, rain may come or rain may not come. So this is what probability is. For example, if it's a very sunny day, the probability of getting rain on that particular day will be very less. It's not sure that rain will come or not, but raining is actually less probable because it's a sunny day. You can actually see the sky and you can actually predict to some degree. So if we use some accurate scientific methods, then you can give much more higher or lesser probability of raining. So that means probability is just prediction of something which can occur or some event which can occur. So if there is an event happening, so there will be multiple outcomes in that particular event. For example, let's say we have a coin. So this is one particular coin which is exactly round in shape and which is actually made of metal. So in this particular coin, if head and tail are there in a particular coin, and if you are actually tossing this particular coin, then at either you may get head or you may get tail. So either one you will get. That means here probability of getting either one is 100% because either head should fall or either tail should fall. That means probability of getting head or tail including both. So then it will be 100% because either this will be there or this will be there. So we are not talking about head or tail. We are just talking either one will be there in the result. So here probability becomes 100%. So let's say I will just choose head as my outcome. So here if I only choose head, then 50% of the times I may get head and 50% of the time I may get tail. That means there is equal chance of getting tail and head when you actually toss a particular coin. That shows how probability works. So when I thought like either head or tail both is fine for me, then probability was 100% because I wanted both head and tail, like either one of head and tail. But when I specifically want head, then my probability will be reduced to 50%. Or when I specifically want tail, then probability will be reduced to 50%. That shows whenever the outcomes increases, the probability will actually reduce for each outcome. For example, let's say we have a dice. So let's say this is a cubical dice which is perfectly cubic in shape, and on this cube you have 1 written on one particular face, 2 written on the other particular face. Like this there will be 6 faces which has 1, 2, 3, 4, 5, 6 as numbers. So here total outcomes will be 6. That means when you toss a coin, there was only 2 outcomes. So in tossing a coin, you had only 2 outcomes. One is head or one is tail. That means either you can get head or tail. So that's why here probability was 50% of getting head and 50% was getting tail. But here, as I told, outcomes when it gets increased, probability will actually decrease. In tossing a coin, only 2 results can be expected. But when you roll a die, then 6 results will be expected. Then your probability will be reduced. That means, for example, getting 1 non-dice. So let's say this is 1. So getting 1 non-dice. So probability of getting 1 non-dice will be 1 divided by 6. Because the possible result which we are expecting is there only once. That means 1 is there only one time on a particular face of a cube. So for example, if this particular dice has 6 faces, then only on one face the number 1 is there, or only on one face the number 6 is there, or only on one face the number 3 is there. So probability for 1 will also be 1 by 6, probability for 2 will also be 1 by 6, probability for 3 will also be 1 by 6. Here 1 doesn't represent the number 1 which is there on that dice. 1 represent one particular face of that particular dice contains 1. That means out of 6 faces of dice, one face contain 1. Out of 6 faces of dice, one face contain 2. Out of 6 faces of die, one face contain 3. So other face contain 4, the other face contain 5, and the other face contain 6. So all these numbers are repeated only one time in this particular dice. So that's why probability out of 6 results will be 1 by 6, because 1 out of 6. So there are 6 different outcomes, out of which we are expecting one particular number. Probability of that particular number will be 1 by 6. That means out of 6 results, there is 1 by 6th of chance getting that particular number which you are actually expecting on a dice. So here you can actually see 1 is there, 2 is there, 3 is there, 4 is there, 5 is there, 6 is there. So total probability is 1 by 6, 1 by 6, 1 by 6. So that means 1 by 6, 1 by 6 should be repeated 6 times, because you have 6 particular outcomes. So when you add up this, then you will actually get 6 by 6. That is actually equal to 1. That means it is actually equal to 100%. So getting either one face is actually surely there, because either you may get 1, 2, 3, 4, 5 or 6. So in this 6 results, either you will get one result. So if you are just considering probability of getting any face, then probability will be 100%, because out of 6 any face will be there. But when you specifically say I want number 2, then probability will be 1 by 6. If you specifically say I want 4 on the face of dice, then probability will be 4 by 6. 1 by 6. Because 4 is there on only one face of the cube. So if you want 6 on that particular rolling of die, like if you roll a die, if you want 6 as your result, then probability of getting 6 will be 1 by 6, because 6 is there only on one face of that particular dice. So here you should understand that probability of getting each faces is 1 by 6, but not always that will be true, because in reality it may vary also. So this also you should actually think, because I may say mathematically head or tail might fall. For example, let's take the first example. Like we are tossing a coin, either we may get head or we may get tail. But here only 50% chance of getting head and 50% chance of getting tail is there. That means if you actually toss a coin for 10 times, then either you may get head or you may get tail. That means 5 times you will be getting head, 5 times you will be getting tail. So according to this particular probability. Here all the time it is not the same case, right? Sometimes you may get 6 and 4, sometimes you may get 7 and 3, sometimes you may get 8 and 2, or sometimes it might be reverse also. You may get 2 heads and 8 tails. Like this also you may get. So whenever you increase the number of trials, for example, here I have written a number 10. 10 shows that 10 times I am actually tossing a coin. So after tossing 10 times, I'll be deciding what is the percentage of getting head and what is the percentage of getting tail. But here I may get 2, 8, 5, 5, 6, 4, 7, 3 or 8, 2. That shows probability is actually not exactly 50% and 50% for head and tail. It may vary. Why? Because the trials which we are taking is very, very less. So now if you take 100 trials, or if you take 1000 trials, or if you take 10,000 or 1 lakh trials, then it will be closing to 50%. That means getting head and getting tail will be closing to 50%. So that shows you only when you increase the number of trials, then only you will actually notice the exact probability which is actually predicted, like 50% getting head and 50% getting tail. So this is what you should actually understand in this particular probability chapter. So when you actually toss a coin, so tossing a coin is actually an event. So an event has different outcomes associated with it, because this particular event causes outcomes. Like, for example, when you actually toss a coin, you may have two outcomes. One is getting head and the other is getting tail. So that means these two outcomes, like head and tail, is actually accompanying the event. So in this event, both head and tail may be possible. Even in while you roll a die, then also there will be six different outcomes. So all those six different outcomes will club together to form one particular event, that is rolling a die. Similarly, getting head or tail is an outcome. So when you mix that outcome, then tossing a coin will be an event. So all the outcomes are actually included in a particular event. So this is what probability is. So if you're actually taking a chance of tossing a coin, then there is a particular event. So in that particular event, you have two outcomes. So that is head and tail. So like this, for every activity which you do, there will be an event occurring and there will be multiple outcomes associated with that particular event. So all those outcomes will be clubbed together for that particular event. So this is what probability is. This is what you should actually understand. So when you closely look upon probability, then only you will understand what is it. Like how much percentage of probability you are expecting for a particular outcome to come from an event. For example, if you are writing an exam, then, and let's say only full marks is given, like not half or 0.25 marks is given in that particular exam. Like for example, if you are writing an exam for 100 marks, then only 1, 2, 3, 4 will be awarded. Not 1.5, 2.5, like that numbers will be not awarded. Let's say only natural numbers are awarded in that particular examination. So at that particular point, if you are writing that exam for 100 marks, either you can get marks from 0 to 100. You cannot get the marks above 100. That shows you are actually, the outcome of your exam results is 100, because out of 100 numbers, you may get any one particular number. But you will be having some sense that you may get in a particular range. That means you may get marks in a particular range. Let's say like from 50 to 60, or you may think that you may get 70 to 80. Based on how you have written the exam, you will be having certain amount of prediction of your results from your exams. So you will actually predict your number, your marks might be in between 70 to 80. Yes, of course, there is outcomes, like all 100 outcomes are possible from 0 to 100. But in that particular range, the probability will be highest, because you will be expecting more marks, or you will be expecting marks in that particular range, because you will be knowing for how much marks you have written the exam. So here also probability plays a different role. So like this, there are a lot of examples in your life itself. When you actually look carefully into it, you will actually understand how much amount of probability is actually involved in every point of your life. So this is one thing you should actually remember. Even probability can be predicted for the raining in a particular season. For example, let's say this particular season is rainy season. Then in rainy season, probability of raining will be 8 days out of 10 days. That means if you have 10 days in a row, then in that particular 10 days, 8 days might be raining. That is because it is a rainy season. Because it is rainy season, 8 days out of 10 days will be actually raining. So if you consider summer season, or if you consider winter season, so in those particular days, 2 days or even 0 might be the probability. So if you are considering winter season, there also raining might be different, because in winter season sometimes you may get rain or sometimes you may not get rain. So here also probability will be from 0 to 10 days as well, because if some natural phenomena occurs and if all 10 days rains, we don't know. Or if because of some natural phenomena, if even 1 day is also not raining out of 10 days, that is also possible. That means all kind of possible outcomes are there in a particular prediction. So if you are actually predicting rain in next 10 days, in rainy season you can tell, okay, 8 days it may rain in this particular 10 days. Or you may say like 5 to 6 days might rain in this particular 10 days. And if it is winter season, you may predict, okay, 1 or 2 day might rain or it might not rain for any days in that particular 10 days. So like this, you can make lot of predictions based on the data available. So always when you actually predict a certain event, then you are actually predicting based on the present situation, based on the present data available. For example, weather forecast has given you a data of having a cyclone in next 3 days. So at that time, chances of raining will be more. And if you have a weather forecast report where it says there is no cyclone in next 10 days and you are living in a winter season, so at that time you can actually predict there will be no rain in next 10 days. So based on the data which you have in the present, only based on that you can make certain predictions. You can make certain possible outcomes. So including, when you include all those possible outcomes, then it will become an event. For example, raining is an event. So in that raining, so in that particular event, there is lot of outcomes. It may rain, it may not rain, it may rain for few time, or it may rain, or it may stop for few time. So like this, there are a lot of outcomes present in a particular event. So all these things you should actually remember while actually giving a probability analysis of a particular event. So after discussing so much things about probability, event, outcomes, etc., etc., now we can actually solve the exercise which is there in this particular topic. So coming to the next exercise in this particular chapter, which is related to probability, that is actually exercise 4.2. So in exercise 4.2, let's see what is the first question. So in this first question, they have actually asked, list the outcomes which you actually get by these particular events. For example, coming to the first question, in this particular first question, they have a wheel like this. So in that wheel, they have actually made 5 divisions. So this is 1, 2, 3, 4, 5. So 5 divisions are there. On 2 divisions, there is A, and on 1 division there is B, on another it is C, and in the 5th division there is D. So here you can see in 2 divisions there is A. So in 3rd division B is there, 4th division C is there, 5th division D is there. So you should actually tell what are all the possible outcomes in this particular event. So here answer will be A, B, C, D, because even when you spin a wheel, for example, an arrow mark is there here, and if you are spinning this particular wheel, at which particular point that wheel might stop. So either it may stop at A or B or C or D. So there are 2 A's in this particular wheel. So even though there are 2 A's, both will account for the same outcome, because both has A in it. So both will be same outcome. So instead of writing 2 times A, I'll just write 1 A, because that is the one outcome which is actually possible. So next is B, next is C, and next is D. So these 4 outcomes, so these 4 are the results which are possible when you actually spin this particular wheel. So coming to the second question, they have actually asked tossing 2 coins. So let's say you have 2 coins. So if you toss 2 coins simultaneously, then what are all the results you may get in this particular tossing of 2 coins? So you may get head, or you may get head tail, or you may get tail head, or you may get tail tail. That means first coin might be head, second coin might be head, first coin might be head, second coin might be tail, first coin might be tail, and second coin might be head. So both the coins might have tail as their results, tail as their outcomes. So that means when you toss 2 coins simultaneously, so these 4 are the outcomes which are possible. So when you toss only 1 coin, head and tail, only 2 outcomes are there. But when you toss 2 different coins, so you may get head tail, or tail head, or tail tail. That shows you have 4 different outcomes when you toss 2 coins simultaneously. Similarly, when you toss 3 coins simultaneously, then you will be having 8 outcomes. So that and all things you can learn in your higher classes. So tossing of 2 coins involve 4 outcomes. So those 4 outcomes I have listed here. So coming to the first question in this particular second question, they have given 2 questions in this particular first question. One is A and the other is B. So you are actually rolling a die. So when you roll a die, so here they are actually discussing 2 events occurring. So first event which they have given in the question A is getting a prime number. So a prime number. So when you actually roll a die, and getting a prime number is event, then how many outcomes are actually involved in getting prime numbers? So that is one question. And this B question is not a prime number. So how many numbers are not prime on that particular dice? So how many outcomes are actually possible in this particular event, where not getting a prime number is one event and getting a prime number is another event. So there are different outcomes for these two events, because getting a prime numbers means you should only get prime numbers of when you actually roll that die. Not getting a prime number means you should not get any prime numbers when you actually roll a die. So that is one event, this is one event. So in this event, possibility is 2, 3 and 5, because out of 1, 2, 3, 4, 5, 6, so these are the 6 possibilities when you actually roll a die. So you may get these 6 numbers. So out of which 2 is prime number, 3 is prime number, 5 is prime number. So getting a prime number when you roll a die is 2, 3 and 5. So in second event, so in the question B is actually your second event, that is not getting a prime number. So here left out numbers are 1, 4 and 6. So here also outcomes which are possible in this particular event is 1, 4 and 6. So this is actually outcomes which are present for not a prime number, and this is outcomes present for a prime number in this particular event. So A is one event, B is another event. So in this second question, there is one more question, that is second question. So out of which there is A and B. Here also two events have been given in this particular second question. So in A question, they have given greater than 5. So getting a number which is actually greater than 5. Similarly, they have given second event where it shows number not greater than 5. So number which is actually not greater than 5. So here they have given this is actually number 5. So this is actually number 5. So here they have actually given two different events. One is getting number which is greater than 5 and getting numbers which is actually not greater than 5. So in this particular event, possible outcome is only 6, because greater than 5 is only 6, because here you can see the possible outcomes by when you roll a die is 1, 2, 3, 4, 5, 6. So the maximum limit so only you can get outcome up to 6, and greater than 5 means only 6 will be the outcome. Here when you take no numbers which are not greater than 5, then 1 will be the outcome, 2 will be the outcome, 3 will be the outcome, 4 will be the outcome, 5 is also an outcome, because not greater than 5. Not greater than 5 means it should not be greater than 5. So either it should be equal to 5 or less than 5. So like that you can have 5 outcomes, because starting from 1 till 5 you have 5 different outcomes for this particular event. And in first event, like in the question A, so they have been asked greater than 5. So in that particular event only one outcome is actually present, that is 6. So this particular number which is getting greater than 5, this is actually known as event, and the results which are possible are known as outcomes. Here also you can see number greater than 5. So numbers which you get greater than 5 is an event, and in that event you are actually getting 5 different outcomes, that is 1, 2, 3, 4, 5. So coming to the third question in this particular exercise, again you have 3 questions in this particular exercise. Let's see the first question, that is A question. So in this A question, they have actually linked to the first question which you have solved. So in first question, we have actually listed the number of outcomes. Like when you spin a wheel, so let's say this is a wheel which have 5 divisions, and on this particular wheel, 2 divisions have A on it, and 3 more divisions have B, C, D on it respectively. Here they have asked what is the probability of getting D when you actually spin this particular wheel. So here you can see 5 different columns are there. So here you can see 5 different columns are there. So total possible outcomes are 4, that is A, B, C, D. So when you actually consider the probability, you should consider all the divisions which are actually divided on that particular wheel. So whenever you take outcomes, number of outcomes may vary, because here 2 particular divisions have A on it. So including those 2 divisions, you can generally say the outcome from those 2 divisions is A. So outcome from remaining 3 divisions will be B, C and D. So total outcomes will be A, B, C, D. So that is actually 4. But when you consider the probability, you should consider all 5 divisions because all 5 divisions are equally divided on that particular wheel. So you should actually consider all the divisions which are there in this particular wheel, and that you should actually put on denominator. So 5 divisions are there. So I am putting 5 in the denominator. So this is actually probability P. So probability P is actually equal to 5, and D is there on only one particular division out of 5 divisions. So that's why 1 by 5 will be the probability for this first question. So coming to the second question, that is B question. So getting ace out of 52 cards. So for example, there is a deck of cards, and in that deck of cards, if 52 cards are there, then ace, what is the probability of getting ace? So probability P is actually equal to, so total number of cards which are present is 52, so that's why I'm taking 52 in the denominator, and number of ace which is there in that particular cards is 4. So 4 by 52 will be the answer. So 4 by 52 is 1 by 13. So 1 by 13 is the probability of getting ace in that particular 52 cards. So don't bother about this particular cards related question. You just bother about the concept. Like what is probability, what is event, what is outcome, and what are all the probability you can calculate by the existing outcomes and event which is present. So only on these particular things you should actually focus on. So coming to the C question in this particular third question, there is a particular bag. In that bag there are 4 red apples. So let's say there are 4 red apples and 3 green apples are there. So in that particular bag, 4 red apples is there and 3 green apples are there. So what is the probability of getting a red apple is the question. So here you can see total number of apples is 4 plus 3, that is 7. So out of 7 you have 4 red apples. So what will be the probability? 4 by 7. So probability P will be equal to 4 by 7 for this particular question, because total 7 apples are there and 4 red apples are there in that particular basket. So out of 7 you can get 4 times red apple. So that's why 4 out of 7. So that is the probability of getting red apple from this particular basket. So this 4 by 7 is the answer for C question. Coming to the fourth question, they have actually given a situation where they have actually generated 10 pieces of paper. They have actually taken 10 pieces of paper. On each piece they have written one number starting from 1 ending till 10. So they have not repeated the numbers. So for example, in first paper piece they have written 1, in the second they have written 2, they have written 3 on the third. So like this on all 10 pieces they have written from 1 to 10. So that means no number is repeated in this particular paper pieces, and all different 10 pieces have numbers starting from 1 to 10. So by giving this particular situation, they have given certain set of question in this particular fourth question, which you should actually go on answering. So there are like 10 different paper pieces here. So coming to the first question in this particular fourth question. So the first question is getting number 6. So what is the probability of getting number 6? 6 is there only one time in this particular list. So out of 10, 6 is there only on one paper piece. So that 1 by 10 will be the probability, because 10 is the total results which can be existing, because starting from 1 till 10, so there are 10 different possible outcomes in this particular event. So here out of 10, only one particular paper piece has 6 on it. That means so only one paper piece has 6 on it, hence 1 will be there on numerator and 10 will be there in denominator. So probability of getting only 6 will be 1 by 10. So coming to the second question, they have asked getting a number less than 6. So this is actually the symbol for less than. So how many numbers are there less than 6 in 1 to 10? So 1 to 5 is actually less than 6. So here you can see 1 is less than 6, 2 is less than 6, 3 is less than 6, 4 is less than 6, 5 is less than 6. That means 6 you cannot take, because 6 is actually equal to 6. You should only take the number which is less than 6. So only possible outcomes are 1, 2, 3, 4, 5 in this particular event. So what is the probability of this particular event? So P will be equal to, there are 5 different outcomes out of 10 outcomes. So that's why it will be 5 out of 10. So that means 5 by 10. So 5 by 10 you can actually write it as 1 by 2. So the probability for this second question in this particular fourth question is 1 by 2. So coming to the third question in this particular fourth question, they have given getting number which is actually greater than 6. So initially in second problem they have asked getting a number less than 6. Now they are actually asking getting a number which is greater than 6. How many numbers are there greater than 6 out of 1 to 10 paper pieces? So there are only 7, 8, 9, 10. So only 4 paper pieces are there. So possible outcomes in this particular event is 7, 8, 9, 10. So that means possible outcomes are actually 4. So whenever you calculate probability, so on numerator possible outcomes should be there. In denominator total outcomes should be there. So total outcomes will be there in denominator. Similarly, possible outcomes will be there on numerator. So these are all the possible outcomes for this particular event, getting number greater than 6. So that is actually equal to 4, and in denominator total outcomes is 10. So 4 by 10 is actually equal to 2 by 5. So probability of getting a number greater than 6 will be 2 by 5. So coming to the fourth question in this particular fourth question. So getting a number which is actually single digit. So getting number which is actually single digit. So getting single digit number. So you should actually find that particular probability. So single digit means 1, 2, 3, 4, 5, 6, 7, 8, 9. All these 9 numbers are single digit. 10 is actually 2 digit number. So 10 you cannot take in this particular event. So getting a number which has only single digit is like how many outcomes are there in this particular in this particular event? There are 9 outcomes where you can get results as 1, 2, 3, 4, 5, 6, 7, 8, 9. Probability will be 9 by 10 because possible outcomes are 9 in this particular event and total outcomes is 10. So probability for this fourth question will be 9 by 10. So coming to the fifth question in this particular exercise, they have actually given there is a spinning wheel like this and it has like 5 divisions on that particular spinning wheel. So all these 5 divisions are equally spaced. I have just written it as a rough diagram. So on this 3 divisions will be of green color. So first, second and third division will be green color. Fourth division will be blue color and fifth division will be red color. So based on this they have actually asked 2 questions in this particular fifth question. So in that particular fifth question, so the first question which they are asking is getting green on this particular spinning of wheel. So if an arrow mark is there like this and if you spin this particular wheel, what is the probability of getting green? So the probability of getting green will be 3 by 5 because possible outcomes of getting green is 3 because only 3 divisions are green. So there are total 5 divisions. So 5 different outcomes are possible. So total outcomes is actually 5 and you want only green as your outcomes. So that is actually you are predicting, like you are expecting outcome. So that expected outcome will be in numerator and total outcomes will be in denominator. So 3 by 5 will be the probability of getting green sector. So this is actually answer for first question. Coming to the second question, getting non-blue sector. So what is the probability of getting non-blue sector? That means other than blue, if you get any other division, then that is actually satisfied. That means you should not get blue, you should get other colors other than blue. So here, what are all the sectors have non-blue color? Here red is also non-blue, green is also non-blue. So 4 divisions are actually non-blue and 1 division is blue color. So out of 5 divisions, 4 divisions are non-blue. So that particular 4 will be in numerator and total outcomes, that is 5, will be in the denominator. So the answer for this second question in this particular fifth question will be 4 by 5. Coming to the sixth question, they have actually asked to calculate probability of second question, whatever the things are there in second question. So you should actually find the probability of that. So on each face there is one number, like starting from 1 till 6. So when you roll this particular dice, there are like 2 questions in this particular second question. In that 2 questions, again there are sub questions like A and B. So you should actually calculate probability for all those things. So coming to the first question, like A question out of first question in this particular second question. So there we have actually told to calculate the outcomes which is present for getting a prime number. So if you want to get a prime number, then what are all the outcomes possible? So here we have actually discussed 2, 3 and 5 are the outcomes which is actually possible for this A question in first question, in this particular second question. So that means 3 possible outcomes are there, and total outcomes when you roll this particular die is actually 6, because you can get 6 particular outcomes as total outcomes when you actually roll a die. So that will actually go for denominator. So probability for this will be 3 by 6. So 3 by 6 will be 1 by 2. So 1 by 2 is the answer for A question in first question in that particular second question. So coming to the B question in this particular first question, they have given not a prime number. So what are all the outcomes we have got for not a prime number is other than this 2, 3, 5. So the remaining numbers other than 2, 3, 5 is 1, 4 and 6. So again here probability will be 3, because we have 3 possible outcomes, and total outcomes when you roll this die will be 6. So it will be again 3 by 6, which is actually equal to 1 by 2. Coming to the second question in this particular second question. So this is actually sixth question. They have actually asked to find out probability which is there in this particular, which is asked in this particular second question. So in second question they have just asked to calculate number of outcomes. So in sixth question they are actually asking to calculate the probability of those particular event. So coming to the second question in this particular second question. So in that A question is actually saying getting a number which is greater than 5. So what was the outcome possible? 6 is the only outcome possible, because in 1 to 6, 6 is the only number which is greater than 5. So you have only one outcome possible. So here only one outcome is possible, and total outcome when you roll a die is actually 6. So 1 will be in numerator, that is possible outcome, and the total outcome will be in the denominator. So that is 6. So probability will be 1 by 6. Similarly, coming to the B question, getting a number which is actually not greater than 5. So it should actually be less than or equal to 5. That means the number should be less than or equal to. So the symbol for less than or equal to is like this. You should actually write like this. If you write this particular symbol, then that particular symbol denotes that less than or equal to. So here this particular symbol is actually less than or equal to 5. Less than or equal to 5 means which is not greater than 5. So here 5 is also included. This I have already discussed with you while solving the second question. So what were all the outcomes possible there? 1, 2, 3, 4, 5. So total 5 outcomes are actually possible, and total outcomes when you roll this particular die is 6. So possible outcomes are 5 and total outcomes is 6. So probability will be 5 by 6. So 5 by 6 is the answer for this particular B question in second question. So this is all there in this particular exercise and in this particular chapter as well. So I have explained to my maximum extent about this particular topic. So you can look at more examples which are there around you, and you can actually try to calculate probability of it. And even you can actually start collecting the data and try to plot different data on a graph. So you can actually learn how to plot graph, and you can also learn how probability works. So this is all what I have explained in this particular video. Like this, I will be putting more and more videos related to physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel and stay tuned with my channel. Thank you.